Hi, welcome back to General Chemistry. I'm Jim Burnham. Today we're talking about solving problems. This is Chapter 4. Remember in Chapter 3, we talked about making accurate measurements. We talked about the metric system. Today we're going to apply some of those concepts to actual problem solving. Now, before we begin, let me ask you a question. Do you like word problems? Word problems like this. Vera and Vicky are sisters. Vera is 4 years old and Vicky is 13 years old. What age will each sister be when Vicky is twice as old as Vera? Are you like this guy? Few chemistry problems will be this difficult. It won't be as difficult as algebra or algebra 2. But you will need to have a problem-solving plan. You will have to have a strategy. It's just like if you're planning a trip. You need to know where you're starting, where you're going, and then how you're going to get there step by step. So a useful three-step approach for problem solving, especially in chemistry, is known as ACE. The ace of spades. Analyze, calculate, evaluate. ACE. So step 1, analyze. You're going to list what you know. What are your knowns? Then list your unknowns. And very often that will suggest to you the right formula for finding those unknowns. So list your knowns, list your unknowns, and try to identify the formula or the calculation that you'll need to solve for what you don't know. That's step 1. Step 2, you're going to perform the calculations. You're going to solve for the unknowns based on the formula that you determined you needed in the previous section of analysis. And then the third step is you're going to evaluate your answer to see if it makes sense. If you're looking for something that's very big, is it a big number? If you're looking for something that should be around half, is it around half? So you use some common sense calculations or just estimations to say, hey, is this result consistent with what I was expecting? As importantly, is it in the right units? Have you expressed it with the right significant figures? This takes us to the concept known as conversion factors. You will be using conversion factors a lot to solve chemical problems. So this concept is one of the key ones. Remember that quantities can usually be expressed in multiple ways. For example, you can say $1, but that also equals 4 quarters, which also equals 10 dimes, or 20 nickels, or 100 pennies. Those are all equivalent expressions. They all mean $1. It's the same with scientific quantities. 1 meter equals 100 centimeters equals 1,000 millimeters. These are simply different units to express the exact same length. And when you have things that are identical, if you have 2 equivalent measurements, you can make a ratio of one to the other called a conversion factor. So a conversion factor is simply a fraction obtained from an equality. 2 things being equal, I can make a conversion factor. I can say 1 meter in the numerator is equal to 100 centimeters in the denominator. I can also flip that around, as we can see. I can say 100 centimeters in the numerator over, say, 1,000 millimeters in the denominator, depending on what I want to do with those units, and we'll see that in just a second. So we can make a fraction anytime we have an equality. We can say 1 meter is to 100 centimeters, or we can flip it. They can be inverted to give 2 conversion factors, and this is true for every equality. Every equality will give you 2 identical conversion factors. The only difference is that the place of the numerator and the denominator. So here are some common equalities, and you can make conversion factors out of all of these. 1 foot is 12 inches, a yard is 3 feet, kilometers 1,000 meters, 2.54 centimeters is 1 inch, and that's an exact definition. 1 meter is 1,000 millimeters, and so on. So all of these can be turned into conversion factors. I could say 1 milliliter over 1 cubic centimeter, or 1 cubic centimeter over 1 milliliter. And they can all be flipped because they're equalities. They're in a 1-to-1 ratio. So I can say 3.3 feet to 1 meter, or 1 meter to 3.3 feet. So all of these you can express them in inverted form, flipped form. This takes us to a super important concept known as dimensional analysis. One super easy way to make sure your answer is correct is to simply keep track of all the units so that you go from the units that you want, or the units that you're starting with, and you cancel out and you get to the units that you want in your answer. So keeping track of units to solve problems. Specifically, you're going to plug in conversion factors. That's these sorts of things. You're going to use the flipped or the unflipped form. You're going to use one of these two forms to cancel out the units you don't want until you wind up with the units in your answer that you do want. So you're going to have some units at the beginning that you start with, and you're going to go to some units at the end. And dimensional analysis just says keep track of those until you have the answers that you want. And that is a very sure way that you've done the problem correctly. So just more generally, you have some given units. You're going to multiply it by a conversion factor where you have your desired unit in the numerator and the unit you're trying to get rid of in the denominator. And when you do that, this unit will cancel with this unit and will leave you with your answer in the desired unit. So let's try some problems. Let's convert between units. How many seconds are there in a school day? Well, how many hours are there in a school day? So let's say our average school day is 8 to 3. So that's 7 hours. So we need to go from 7 hours and convert to so many seconds, however many seconds. So here's our dimensional analysis. So we're going to start with the units we don't want, and we're going to multiply them by a conversion factor that has these units in the bottom, the denominator. So one unit that we can easily come up with, if we've got an hour down here to cancel out these hours here, what do we know is in an hour? We know there's 60 minutes in an hour. Great. So our hours would cancel. We'd be left with minutes. But we're looking for seconds. No problem. Now I have a new number that I want to get rid of. I want to convert minutes to seconds. So I have another conversion factor. I put 1 minute down here. And how many seconds are in a minute? 60 seconds are in 1 minute. Notice that each of these are identical. Right? They're just different ways of saying the same thing, which is why we can create an equality, a ratio, a conversion factor out of them. So now my minutes cancel, and I'm left with seconds in my answer. Now I just do the calculation. 7 times 60 times 60 divided by 1 is 25,200 seconds. How about converting complex units? So this problem we converted a single unit. And that's a simple conversion problem. But you can have more complex problems where you have 2 units that you need to convert, and you need to convert them both. So complex units are ratios of 2 units. For example, speed. Speed is usually expressed in miles per hour. And let's say you wanted to go from miles per hour to meters per second or something like that, or kilometers. Kilometers per hour would convert the second. Or density, for example. Density is expressed in grams per cubic centimeter, but maybe you wanted to express it in some other units. So converting 2 units at the same time is a complex unit conversion. And we're going to use multiple conversion factors. Why? Well, we're going to multiply one conversion factor or more to get rid of the units in the numerator, and then we're going to focus on the denominator and get rid of the units in the denominator and turn those into the units in the answer that we're looking for. So first convert the unit in the numerator, then we focus on the denominator. You're going to have multiple conversion units, at least 2, if not more. So let's try an example of this. Let's convert the units feet per second and convert that to miles per hour. So the first thing we're going to do is get rid of our numerator into what we want. So what we want is, instead of feet, we want miles. So let's put feet down here and create a conversion unit that relates feet to miles. How many feet are there in a mile? 5280 feet per mile. Great, that cancels out my feet and leaves me with miles. All right, I'm halfway there. I've converted my numerator, now I have to convert my denominator. So now I need to get rid of seconds and turn them into what? Into hours. So what do I need to do? I need to put seconds up here so they'll cancel with my denominator and leave me with what I want, hours. So how many seconds are there in an hour? And if you don't know this, you could go from seconds to minutes and then minutes to hours. But in any case, if you do know this, it's 3,600 seconds per hour. So here are your two conversion factors to convert each of your numerator and denominator units from what you start with to what you want. Feet to miles, seconds to hours. So you'll get word problems, but these will be chemical word problems, and you can solve these with dimensional analysis and conversion factors. A car traveled 60 miles on a road in 2 hours. How many feet per second was the car traveling? Right. Here's a hint. Set up the words first. So the car was traveling 60 miles in 2 hours. So that's 60 miles per 2 hours. And what we want to get to feet per second. So here's what we're going to do. We're going to cancel out our miles to feet, and then we're going to cancel out our hours into seconds. Anyway, so here we go. 60 miles per hour, 60 miles every 2 hours. We're trying to cancel out miles, so we put mile down here, we turn it into feet, that's what we're looking for, 5280 feet per mile. All right, now we've converted miles to feet, okay, that's there. And how many, now we want to get rid of hours and turn them into seconds, all right? So we're going to put hours up here to cancel out the denominator. And how many seconds are there in an hour? You might have to do a mini conversion here, but you can do it. It's 1 hour is 3,600 seconds. And then you do the math. 60 times 5280 divided by 2 divided by 3,600. And you're going to get this answer, 44 feet per second. So we've converted from 60 miles in 2 hours to so many feet per second. And we did that through a series of conversion factors, and we did that with using dimensional analysis, keeping track of our units, getting rid of the units we don't want, and turning them into the units that we do want. That's it. Thank you for your time.